So that is the criteria or conditions for validation testing. Okay. So next is alpha beta testing. Alpha beta testing, all these are the small types of testings. Okay, in CO4, if you see, we have all the types of testings. Okay, CO4 is mainly of types of testings. Okay, so this is alpha beta testing. Okay, what is alpha and what is beta testing is, as the name specifies, the only difference is or not the difference, the similarity between alpha and beta testing is both will be done with the user case. Both will be done with the user case. That is the similarity. And the difference is alpha testing will be done testing in the user place by user and sitting aside with the developer. Okay. So both the end user and the developer will be sitting together on the at the uh, at the user end, and they will be tested. That is called alpha testing. And beta testing only I am the user, only I am checking individually without anybody's help. Without anybody's help or without anybody's present like developer or any expert, nobody is there. Only I am checking. Okay, that is called beta testing. Okay, so all this what I have mentioned, we have came across all the types of testing. Okay, all the types of testing will not be implemented for any particular application. Okay, the particular application will be deciding whether or the software tester will decide which type of test or which criteria of test has to be implemented based on the application or based on the software product. Okay, but most probably alpha testing and beta testing, 99% it will be implemented in all types of testings. Okay, because this is done at the user place. Okay, because after the development, after the testing, yes, the product may be successfully running in the developer place, but when you take it to the end user, it may not run. It may not support some features. Okay, but that is the responsibility of the developer company, developer organization to rectify the problems. Okay, so this comes under the delivery and feedback. Delivery and feedback. Okay, so even after the delivery, even after the construction, coding, testing, it is the responsibility of the organization to go to the end user place, install it, test it whether it is working properly at the end user location or not. Okay. So next is system testing. Okay. So system testing is uh, all the in this scenario. Okay, the developer has written the code. Okay, no problem, all successful. The tester has done all the testing. Yes, no problem. But when you get the final product, when you get the final product, that may that may cause some error. That may cause some error which has been missed by the developer or the tester. Okay, what happens at the time? What happens at the time? The product or the organization will be blaming each other. This is the responsibility of tester. This is the responsibility of a developer, or this is the responsibility of the manager. Okay, so this type of problems can be rectified when you get your final product. Okay, system testing will be done at the last. Okay, when you have a successful product, when you have a successful completed all uh, all requirements satisfied, all bug free software, bug free code. Okay, then it may it is not mandatory that it will cause error. Okay, it may or it may not cause some error. Okay, that type of errors can be identified by system testing. That can be identified by system testing. Okay, there is again a series of different tests. Okay, which can be exercised based on the computer-based system. Okay, which will identify the errors. Okay, which is missed by both the developers and the test. That type of testing is called system testing. Okay, so next is the recovery testing. Okay. When you develop a software or when you develop a software product, the recovery is very important. The recovery is important because a system may fail. A system may fail due to various reasons. Okay, due to various reasons at various circumstances. Okay, so to avoid the data loss, to avoid the data loss or the network loss, okay, we should have a recovery system. We should have a recovery system, or we should have a recovery procedure, okay, to get back to the previous stage or previous version, okay, so that the data loss will be the minimum one. So that the data loss will be the minimum one. On that. So that is called recovery testing. Okay. So simple example of this one is when you, even if you see the Windows, it has an option when you install a Windows OS in your laptop or your system. It will ask for an option. Okay. If you want to install a fresh copy or if you want to repair the OS. Okay. So what is repair? It is just a recovery to the previous state, or it will add the features which is only the problem. Okay, only the problem it will identify, it will be sort out, and it will get back to the original state. That is called a repair in Windows OS. Similarly, whenever you are doing a software product, okay, software development life cycle, you should have or you should plan accordingly for a recovery procedure or recovery test. Okay, so the what is the purpose of recovery test is when it fails, due to some unavoidable circumstances, it should get back to the back state with a minimum data loss. Okay, that recovery procedure or recovery process is that process has to be tested. That process testing procedure is called recovery testing. Okay, and next one is security testing. And both the all these three are interlinked: recovery, security, and stress. Okay, security. Why a system will get failed or it will get failed due to circumstances? You should apply a recovery to avoid the failure. You should do security testing. Okay, and you should build a system such that it should accommodate the enormous or abundant functions or features or quality of volume. That is called stress testing. Okay, so all these are interlinked. All these three are interlinked. If you are constructing a system, if you are constructing a process, okay, software development life cycle, if you don't want to get it failed, you should improve your security. You should improve your security, and you should create your system such that it handles all the stress. Even after this too, it fails, it should be in a position to recover. It should be in a position to recover. So these three are interlinked. Okay, so stress testing for a system, for a product or the software development life cycle, whatever the quality, whatever the quantity of volume you give, or whatever the frequency of volume you give, it should not fail. It should not fail. That testing is called stress testing. That testing is called stress testing. It is based on the resource abundant. Okay, resource availability. A simple example of stress testing is, okay, if you have a Wi-Fi modem, okay, if you have a Wi-Fi modem, okay, normally if you connect one system to a Wi-Fi modem, no problem. Two systems, no problem. Five systems, no problem. Okay, what happens if you connect 50 systems into a one single modem? Okay, that position is 99%. A simple homemade modem, home purpose modem will not satisfy that purpose. Okay, you need a router or something else. Okay, so a maximum homemade uh, home purpose modem, modem, right? Router. Okay, that router can handle maximum of 10 or 15 systems at a moment. That is the maximum limit, and that is tested by stress test. Okay, so all these three testings are interlinked, and all these three testings are done for the avoiding of failures due to various circumstances. What is the various circumstances? due to power connection or due to some electrical problem or due to some system error, driver errors, okay, OS errors. All these are some unpredictable circumstances error. Okay, you may not know when your OS will get corrupted. Okay, it will be working today very fine. Okay, super, very good. But tomorrow morning when you switch on your system, your OS may get corrupted. Okay, so all this can be rectified using these three types of testing procedures. Next is performance testing and deployment testing. Okay. Performance testing is again similar runtime performance testing. Okay, when you integrate all the unit testing, you have completed all unit testing, integration is done. You got a single product. When you get a single product, you do system testing. Okay, and you do performance testing also. Okay, just to cross check whether all the testing process is completed, all the satisfied is done or not with respect to both hardware and software instrumentations. Okay. Deployment testing again this is the configuration. Okay, deployment in your system or in an end user system or in a public system. Okay, that is called deployment system. Okay, for an example, if you take a ATM machine, if you are taking an ATM machine, okay, ATM machine software is developed, all the backend, front end, all the procedure is developed. It is working fine in the developer end. Yes, okay, done successful. Then you will go to the bank, you will do the backend process, all is successful. But if you get error in the front end means the ATM machine. If you get an error in the ATM machine, then it may be a problem for the entire system. If your front end is not working, then you will not get any data in backend. And again, all the process is waste. So deployment in all the procedures, in all the environment. Okay, that is called deployment test. Okay, it should be deployed in all the environments wherever it is required. Deployment means in simple installation of software. Okay, and deployment in simple, it can be referred as installation of software wherever it is required in the end user. Okay, in the end user's front end. Okay, all this it has to be used. All this it has to be verified. The verified procedure is called a deployment testing. Okay. Okay. So next is uh, test-driven development. This is also one of the important questions in CO4. Okay. What is test-driven development is? It is not a testing procedure. Okay. It is not a software development life cycle. It is a programming practice. It is a programming practice. Okay. What is programming practice? Is you have written a code. You have written a code. Okay. You have tested using some automated test. Okay. In the automated test, it is failed. Then again, you will not delete all the codes whatever you have written. Okay, you will not do that. It is a double work. What you will do is you will just modify or you will just modify only the statements or you will add only the statements which can be made the code such a way that it satisfies all the requirements. Okay. In TDD, test-driven development is also referred as TDD. The modification is called refactoring. Okay. This is a new term which is used in TDD. Refactoring means changing some code without affecting the behavior. What is behavior? Behavior, it should satisfy or it should satisfy or it should have all the features of the requirements. Okay, for an example, if you are developing a chat application, if you are doing a chat application, okay, you are doing refactoring. Okay, refactoring means adding some code. Okay, after adding some code, it should not become some other software. It should not become some word editing document. Okay, that is a wrong procedure. That is a wrong procedure. Even after adding your code, it should be a chat application only. Okay, so that is what it is mentioned. You should add some code or modify some code without affecting its behavior. That is called TTD. That is called TTD. Okay. Okay. TTD again. it is based on the automated test. Okay, what is automated testing? Again, you have set of testing procedures or testing rules from the testing types which we have came across. From that, for an example, unit testing, regression testing, smoke testing. This three testing will be done automatically by the system, and it will generate the report. Okay, automated testing. Okay, if it fails, then what you have to do? It is called test-driven development. Okay. So this is the procedure for the test-driven development. Okay. So first you add a test, add a sorry, add a test, execute a test, make changes to the code, execute the test. Okay, so initially you are adding a test. Okay, you will execute the test. What is adding a test? Adding a test is the test procedure or the testing cases. Okay, for a particular application or a particular code. Okay, just add a test. You will execute. If it passes, then you will add the next. You will add the next test. Okay, if it fails, then you will make changes to the code. Okay, then again you execute. Okay, after changing the code, you again execute. If it fails, then again you make change, execute, fail, change, failed, make change, execute. In a particular moment, it will get fast. It will get fast when satisfies all the requirements, all the code procedures, not changing any behavior. Then, and then what you do? Again, you go back to the first step and you do the process. You do some more tests. You do some more tests, and finally, all the past developments stops. Okay. When it will get stopped, when all the test cases, all the test procedure is completed, and it all get passed without any failure, or it satisfies all the requirements. This is the procedure, or this is the performance flowchart for TDD. Uh, just make a note of it if that way. Okay. This is the procedure for TDD. Again, TDD. Okay, what is TDD? Test-driven development. Okay. It has cycles. Cycles or steps. Okay. Write a test, make run, code, refactor, the repeated process. The same process I have shown in the image also. The same thing is there. This is the cycle of TDD. Add a test, run, write some code, refactor, repeat. The same process. Okay. So this is the life cycle of TDD. Okay, life cycle. I mean, cycle defined by TDD. And again, what is TTD? TTD is not a testing. TTD is not a design. Okay, or TTD is not a writing a separate new code. Okay, or TTD is not doing lot of testing. No. Okay, what is TTD? TTD is you have written a code. You run automated testing. If the automated testing is failed, you just modify, add, or delete some part of the code. That is called the term called refactoring. You do refactoring process, then again you run the test process. This is called TTD. Okay, so TTD is not doing plenty of tests. You run all unit testing, integration testing, white bugs, red bugs, all the types of the types of testing you implement. That is not TTD. Okay. Again, you have two types of TTD, two levels of TTD. One is acceptance TTD, and another one is developer TTD. Okay, acceptance serial line. You write a single acceptance testing. What is acceptance testing? Acceptance testing is when you develop a product. When you develop a product, it should be satisfied or it should be accepted by all the users. It should be accepted by all the stakeholders. It should be a profitable. It should be a profitable code or process or product. Okay, if you have developed a product, it should be a businessly, financially, it should be a profitable product. Okay, it should satisfy all the features. It should satisfy all the functions. Okay, that is called acceptance testing. It's called acceptance testing. Acceptance testing is mostly related to the financial related issues. Okay, you write a single acceptance testing. You write a single acceptance testing. Okay, the test requires fulfills all these requirements specification and satisfies the behavior of systems. Okay, that type of testing is known as acceptance TDD. Okay, if it is not satisfied, then you do the TDD process. Okay, you write acceptance testing, you run acceptance testing. If you have any problem, you refactor. The refactoring is again related to TTD, that is called acceptance TTD. Okay, very simple, easy to understand. Acceptance TTD, acceptance TTD is also known as behavioral driven development. Okay, so in some exam or in some question paper, if you get the abbreviation called BDD, okay, then again it comes back to the behavioral driven development, which is known as acceptance TTD, which is a subpart of TTD. What is TTD? Refactoring the code. Okay. So under TTD, you have acceptance TTD. Acceptance TTD is also known as behavioral driven development. Okay, BDD. Okay, I'm just noting. I just want to say this abbreviations because in some question paper stating that what is BDD, then at that moment you should not wonder what is BDD. Okay, you should not dream what is BDD. Okay, for that. Okay, next type is developer TDD. Developer TDD again you write this is with respect to developer point of view. Okay. Actually, this is the main concept. This is the objective of TDD, test-driven development. The same point, only the name is differing. Okay, if you read the first point, it also tells the same content. Okay. It runs all the testing procedures. If you have any problem, add, delete, modify a little or some parts of the existing code. Do not write a new code or new procedure. Okay, just to modify the existing code such that it is not affecting the behavior and also it should satisfy the requirement given by the customer. That is called developer TTD. Is also known as TTD. Okay, so TTD, developer TTD is the main objective. The same concept, the same point I told in the TTD also. Okay, why? Because why this both are said? Who will do the modification in the code? Obviously, the developer has to do. The modification in the code cannot be done by a manager or cannot be done by a team leader or cannot be done by a software tester. Okay, software tester. So the main goal of ATD and TTD is to execute the requirements. Okay, execute the requirements. Okay, refactoring the code without writing a new code or new procedure for it, and it should satisfy the requirement specifications. Now see the diagram. This is the left side is acceptance TTD. The right side is developer TTD. Okay. So from this diagram, what you can able to understand, is developer TTD is again is a part of or is available inside acceptance TTD. Okay. So acceptance TTD initially you start at acceptance TTD, run it, fail, make little changes, how you will make little changes, you will give it to the developer test. You will give it to the developer, run the developer test, make little changes, fail, do the process repeatedly. After getting it passed, run the acceptance testing. Again, if it fails, make little changes. Again, if it passes, then development continues. And at a moment when all the acceptance testing is satisfied, you come out of the acceptance TTD. So this is the procedure for acceptance TTD and the developer TTD. Okay. So from this diagram, what you understand is developer TTD is available or which is present inside the part of acceptance TDD. What is acceptance TDD? It is also known as BDD. And where is BDD? It is present inside TDD. Okay, what is TDD? Test driven development. What is test driven development? You just have a code. Okay, if you run an automated testing, it fails. If it fails, you refactor the code. Again, you do the process without changing the behavior. Without changing the behavior, and it satisfies all the conditions, all the requirements given by the customer. Okay. Uh, if you want, you just make note of this diagram, or else I'll name this PPT so that it will be useful for your test too. Okay. So next is Agile Model Driven Development, AMDD. Okay. I would like to mention that you remember all these abbreviations, because some places or some questions, only the abbreviations if mentioned, then you should not think it is some unknown topic or some new topic. Okay, AMDD means Agile Model Driven Development. Okay, again, it is a part of it is a life cycle of AMDD. You see the diagram. Okay, it addresses to the agile scaling issues of TDD. Okay. Okay. So what is agile? What is agile? Going back to the basic concepts, what is agile? Agile is next generation software development process model. It is iterative in nature. Okay. Iterative in nature, which is done for a lightweight process. Done for a lightweight process. It is done for a shorter duration. Okay. Again, and inside agile you have three types. One is extreme programming, Scrum, and what is one more? What is one more? Kanban. Okay, so these are the topics under Agile. So what happens if you combine this Agile concept, or if you implement this Agile concept inside the TDD? Inside the TDD, you get Agile Model Driven Development. Okay, so you see the diagram. Okay, so initially you should get the requirements, architecture, model storming, TDD. Okay, and one more point here to be noted: it is not just one process. It is again iterations of process. It is just iterations of process. If you see this diagram, this process is iteration one, iteration two, iteration n. Okay, so it will be running n number of times. It will be running n number of times. Okay, and output of this one is again, it is an executable product which is satisfying all the conditions, all the financial issues, all the acceptance testing, all the testing procedures, and we have got the free software products. Okay. So, so this is called AMDD. AMDD. Okay. So see the diagram, identify the high scope requirement stack. If you need a requirement, you need an architecture. What is architecture? Designing an architecture is again, when compared to the SDLC, it is called design. It is called design phase. Okay. You plan, you plan the iterations. Again, it is an iterative in nature. Whenever whenever you come across or you implement agile concepts wherever you want, it is iterative in nature. Okay, agile concept cannot get output or cannot get a final successful product in one single iteration. It is not possible. Okay, so whenever you implement agile, means you are doing iterative process. Okay, and you do all this process in just in JIT manner. What is JIT? Just in time manner. What is just in time? You produce or you do a task which is relevant or which is required only at the moment of time. Okay, you will not plan. You will not plan for a product or an idea which is required after 10 years. No, okay, for this day, for today, or for this month, what is required, that product or that work you will be doing. That's called just in time manner. That is called just in time manner. You will not plan for a long scale. You will not plan for a long scale for 10 years or 5 years, and you will work accordingly. No. Okay. So this is called AMDD. Okay. So this is just a comparison between AMDD and TTD. This has programming feedback loops. Okay. This has modeling feedback loops. Okay. Why it is this? Again, it is just mainly concentrating on coding. Okay. It is mainly concentrating on field design and section planning. Okay. Sorry. Skip. Okay. So TDD is detailed specification. Okay. Works on bigger issues. When you have bigger problems, you use AMDD. Okay. Again, what is bigger issues? Bigger issues you cannot resolve all the bigger issues in one single go. Okay, one single procedure you cannot overcome all the bigger issues. So you need iteration. You need iteration. You will divide the bigger issue into small. In the first iteration, you will satisfy 10%, next iteration 10%, next iteration 10%. So at the end of all the iterations, you resolve all the bigger issues. Okay. And in TTD, you have high quality of code. In this, you have high quality of communication with all the stakeholders and developers. Again, related to iterations. Related to iterations. After each iteration, you will have a review or a feedback from the stakeholders and developers. You will overcome all the problems in the next iterations. Okay. In this, programmer speaks. In this, business analysis, stakeholders, data professional speaks. Okay. Non-visually oriented, visually oriented. Okay. Scope of work. Also, all these are the difference between TTD and
Deepak sir?
AMDD. Sir,
Deepak sir?
sir, sir, audible, sir? Sir,
ఓకే సార్ మీ వాయిస్ వినబడకపోతే డౌట్ వచ్చింది.
voice is not there?
నౌ క్లారిటీ సార్. ఓకే సార్.
Okay, sir, okay. Okay. Others, Rakesh, Ajay,
Yes, sir.
audible?
Yes, sir.
Sir.
Audible, sir.
Okay, ma, okay, ma. Okay. Okay. Okay, so this is the difference between TTD and AMDD. Okay. So this is the advantages of TTD. Okay. Early bug notification. What is bug? Again, the place or the error where it is notified. Okay. Better design. Better design. Okay. Confidence of refactoring. You modify only the required ones. Okay. Again, refactoring cannot be done by one single person. You need a teamwork. Okay. Refactoring means changing the code. Changing the code cannot be done by one single person. You should need a team of persons to refactor. Okay. And who can do a efficient refactor? You should have a good developer. Okay. So all these are the advantages of TTD. To summarize the same points, modify the code, do the test process, get the test process successful. Yes, problem solved, no issues. Okay, you will not be writing a new code, new product or something. Okay, so this is the summary or this is the content related to TDD. J unit will do tomorrow. Okay. So J unit is actually an automated testing unit. Okay, I'll just give the introduction. We'll do the topic tomorrow. Okay. So J unit is an automated testing. Okay, founded by these two persons, Tech and Gamma. Okay, in Washington DC. What is the use? And it is an open source. It is an open source. You can directly download from junit.org, from junit.org. Okay, and it will do all the test-driven developments. Okay, and it can be implemented in using in any IDE like Eclipse, BlueJ, JBuilder, Dr. Java. Okay, all these are Java. I mean, all these are editors, programming editors. All these are programming editors, okay, which can be used in any programming languages. It can be used in any programming languages. Okay. So before going to that, few points. Okay. You will be having your test two this week. Okay. Most probably. Okay. The official circular will be given by HOD sir. It will be MCQ questions as you attended the normal, your regular subjects. Okay. So, whatever the same procedure, whatever you followed in the regular procedures, regular exams, regular tests. Okay. So, based on this, your internal marks will be calculated. Okay. So, any doubts? Okay. So, any doubts? Any issues? And one more thing, did you all receive your updated schedule for online class? Your next class is tomorrow. Not actually the previous schedule was on 24th. Okay, it is pre-pointed to tomorrow. Okay, tomorrow, same time, 11 to 12, you have the next session. Okay. Who is 574? What's your name? Prasanna is here, Rakesh, Ajay, Harshvardhan, Sai Vishal, Shivashankar, Rohit Harshvardhan, who is 574, I don't know. Okay, fine. Okay, so any doubts, any issues?
Yes, sir.
Okay, so um, read all these testing procedures. Okay, all the types of testings. Okay, you may get all the multiple choice questions, okay, related to testings. Okay, some case based or some definition based. Okay, so all will be MCQ questions only. Okay, so concentrate on all the topics, all the types of testings. Okay, all the types of testings. Because why I am telling this point is, I have, we have discussed all the types of testings. But when you see the syllabus, it will be just white box testing and black box testing. Okay, so if you see the syllabus, it will be just two lines. It will be just two lines: black box testing, white box testing, validation system. Okay, only these types of testing is mentioned. But other than this, we have discussed plenty of other testing types also. Okay, so concentrate on that also. You may get questions from that topics also. Okay, because why it is not mentioned here is it is just a part of all these types of testings. Okay, so unit testing, obviously it is a part of testing. Okay, so no need to mention in the syllabus. Okay, so unit testing is not there, smoke testing is not there, regression testing is not there, but it is a basics. Without knowing the basics, you cannot do black box testing and white box testing. Okay, so study all the topics. Okay, don't leave any topics. Okay, so mainly for all those who got less marks in test one. Okay, this is a good opportunity to improve your test two marks. Okay, improve your test two marks, improve your internals. Okay, so the main objective of the built-in course is to get good internal marks, and only you may clear the external also. Okay. Any other doubts? Any other questions? Okay. Anything else? Similarly, with respect to your regular subjects, CO3 25 marks, CO4 25 marks. Okay. The official schedule will be released by HOD sir. Okay. Shivashankar, Shivashankar, okay. Sai Vishal,
Yes, sir. Yes, sir.
Sai Vishal, you wrote this one.
No, sir.
Okay. Why? What was the problem?
Sir, actually, I was a health issue, sir.
Okay. Okay. And also this. Okay, fine. Okay. So all those who got less marks, all those who got who didn't write test one or any other issues. Okay. So test two is a good opportunity to improve your internal marks. Okay. Read, study all the topics in CO3 and CO4. I will send all these documents to your official mail address. The register number at klnst.in. Okay. See your mails by today evening or tomorrow morning. I'll send the PPTs. Actually, already I've sent it. I think once again, if you want, I will send it. Uh, at the end of the last session, last class in the college. After that itself, I have sent all these documents. Okay. If you have not received, I will send it once again by today evening or tomorrow morning, okay, to your official mail address. Okay. So tomorrow's topic, you have two topics. One is J unit and another one is Six Sigma. Okay, Six Sigma and CMM. CMM. Okay. So tomorrow we will discuss the two topics and we'll complete CO4. J unit again. It is just a well, it is like a big topic, but as far as software engineering considered, it is only introductions and basic parts. Okay. So JUnit, this is a automated testing tool, which can be used to test the code. Okay. So we have come across all the testing procedures. Okay. So how do you execute? How do you implement the testing procedure? Is using JUnit. It's using JUnit. Okay. The testing procedures are the combination of tests. I call test suite. Okay, so it's called test suite. You can create a test suite of your own work, of your own data, of your own testing procedures or testing conditions. Okay, because testing procedure or testing conditions will not be a generalized ones. It is a customized. Okay, you should test or you should write a testing procedure based on the application or based on the product which you are going to do the test. Okay, you cannot write a set of testing procedures and you cannot implement the testing test suite in all the applications or all the products. That will not give an efficient output. Or will not be giving an efficient output. Okay, so always the test suite is an is a customized one. It's a customized one, and as a software tester, you should write the test suite. You should create the test suite using JUnit, and you should be implementing the test suite in your code. Okay, using JUnit. Okay, so the advantages of test suite code test suite is the total number of bugs can be reduced. Okay, you can you can get more or efficient output. Okay, and you can easily identify where or which part of the code is getting it or creating a problem, and you can and it can refactor only that particular code or the only particular that part of code. Okay, it's called refactoring. Okay, so this is the architecture. This is the architecture of JUnit. Okay, this is the terminologies we will be using: test runner, test result, test case, assets. Okay, what type of diagram is this? What type of diagram is this? This is the type of UML diagram, I guess. You see this boxes. What type of UML diagram? Anyone? Anyone? Find out. Find out and tell me tomorrow. Okay. This is a part of UML diagram. Okay. Uh, okay. So the test runners and test results, test cases. Test cases is the conditions. Is the conditions where you will be putting your conditions and you will be and it will be run. Test cases you will, it is as simple as to know is requirements. Okay, you are giving the requirements, you will run it, you will get the result. You will get the result. So this is how you write a test case. This is how you write a test case. A simple Java code. Simple Java code. So say we put JUnit dot framework dot test case. Again, JUnit is a package. Again, it is based on the Java. Okay, JUnit is a package. You can directly import the package, use it in your program. Okay. In this case, in this particular case, you are using a test case class and extending it in the test bowl. Okay. Test bowl is a user-defined class, and you can write whatever code inside it. Okay. So name of the class is more important. So this is how you sorry. So this is how you create a JUnit subclass, okay, through which you can use the JUnit in your code. Uh, uh, these are the methods. These are the methods which is available inside the asset. Okay, asset true, asset false, asset null, asset equals, asset string. Okay, all these are the methods uh, which is there inside the JUnit. Okay, so that's all. Okay, so that's all for today. Any questions? Any doubts?
No, sir.
Okay.
No, sir.
Okay. Okay. Then you can be. Okay. Sir, listen, sir. Sir. Okay. We'll close.